Today's topic is buoyancy. Buoyancy. What is buoyancy? When a body is fully or partially immersed in a fluid and upward force an upward force exerted by the fluid on the body. This upward force is equal to the weight of the body displace weight of the body, weight of the fluid displace by the body. is called force of buoyancy. Force of buoyancy. And the phenomena is phenomenon is called buoyancy. Now next topic is center of buoyancy. Center of buoyancy. What is center of buoyancy? A point at which force of buoyancy acts is called center of buoyancy. Understand? Center of buoyancy. Center of buoyancy is denoted by denoted by capital B. Now, suppose consider a cylindrical body suppose it is floating. Total height is h and this height is x. We know center of force of buoyancy or buoyancy force equal to weight of, this is the suppose this is water, the density rho w, weight of fluid displaced by body, weight equal to weight, you can say rho g into volume. This is mass density, weight density, weight density into volume of fluid displaced. Weight density means rho g into cut. This is Fv. And in this case, in this figure, buoyancy force equal to the density of rho into g into displace pi. This is the diameter is d, pi by 4 d square into x. This is the buoyancy force. Now topic is stability of a submerged body and fully immersed body. There is three equilibrium condition. One is stable equilibrium. What is stable equilibrium? Equilibrium means if W equal to AB, comma, but this is the center of buoyancy is above point B. B means center of buoyancy is above G, center of gravity. Then the body is said to be stable equilibrium. Suppose this is the body or this type body. Sorry. Balloon shape body. This is the body. Is balloon shape. This is the body. This is the, suppose this is the G and this is the B. B is above the G, then stable equilibrium, and this B and G. This is the angular displacement. Angular displacement. Angular displacement. This is weight. This is buoyancy force always acts at B, center of buoyancy upward direction. Now here you can see this is fully immersed or submerged body. This is the submerged body. When a body is given to angular displacement in clockwise direction. This is clockwise direction. This is FB, then FB and weight generates a couple acting on the body in the anti-clockwise direction, and thus the body bringing the body its original position. Hence the body is in stable equilibrium. Body is stable equilibrium. Understand my points. When this is first body, fully immersed body or submerged body, is given to angular displacement in clockwise direction. F and W, weight and buoyancy force. This counter, the sense is counter or anti-clockwise direction. Then the body returns its original position. Then the body is stable equilibrium condition. Understand? Now next point is unstable. Number 2 is unstable, and B is below G. Then the body is said to be unstable equilibrium, and this position is B. This is suppose B, and upward force. This is G. This is upward force, and this sense is when the body is given to act in clockwise direction, generate couple in the clockwise. This also clockwise. Sense is clockwise direction. The body returns to, thus the body does not return to its original position. Then body is in unstable equilibrium. Understand? If W and FB, B is below the B means center of buoyancy, below the center of gravity, then unstable equilibrium. Next, neutral. Next point is neutral. Next point is neutral equilibrium. B is AB, but point B is at the same point. B and G are at the same point. At the same point or coincide at the same point. Then the body is neutral equilibrium. And that time center of B and G coincide, and here the weight is both are same. Understand? Find the volume of water displaced by the body, and position of center of means position of is H. Position of center of buoyancy means this height. Suppose this displace is H. Displace height is H, and the center of buoyancy is this one. Position of the center of buoyancy, and width is 2.5, and depth 1.5 meter, and length is 6 meters. Horizontally floats horizontally in water. The density of block 6 and water density. Now first, volume of wooden block wooden block. Length into width into depth 1.5. The is 22.50 meter cube. Now volume of weight of this is the volume. The weight of fluid, weight of block is weight density into volume. Weight density is block is 6509.81 into 2.250. Understand? So 41347 1 Newton. Understand? Now for equilibrium, weight of the displaced fluid equal to the weight of the block. Weight of the volume of water displaced by the principle of flotation. Weight of wooden block, weight of fluid displaced equal to weight of the body. Weight of the body. This is the principle of flotation. Now rho g and displace the volume of, this is suppose volume of fluid displace